Final unit, unit 11, 11.1. Just going to have one day of this. This is completely different than any unit you've learned in first try or so far in second try. We're going to jump into this whole world of statistics, and it's going to be different. So a lot of vocabulary on this day. So it's really all vocabulary. It's not going to feel very mathy, so maybe this will be a little break for you guys that are just tired of crunching numbers. So consider two questions. In what year is your birthday? So me, that's 1967. Don't do the math. That makes me old. There's an answer. You don't need to do any studying. You don't need to look at information, and it's just a fact. So look at this one. What month has the most birthdays? Well, you wouldn't be able to just go, I know that. You'd have to go out, interview people, discover data, look at the information. Would you really, really want to survey the entire world? No, you don't have enough time. So you're going to take a statistical analysis of it. You're going to take a sample size, ask whatever, 100 people, 1,000 people, 10,000 people. The more people you ask, the more accurate your information is going to be, but you cannot answer this question without really digging into a sample size and then making predictions. So question number 2, you needed to collect data and info to make a conclusion. Now your conclusion might not even be perfect. Close, but you have to summarize all that data and info that you collected. So therefore, question number 2 is considered a statistical question. So it's just a phrase, and you're going to be asked, is this a statistical question or not? So if it's just a fact, then it's like, nope. If it's something you have to go investigate, do a little survey sample, and make a conclusion, then it's yes. So very similar to the questions that I just had on the board about birthdays and what is the most common month to be born. Those were in like question form, and you had to determine which one's statistical, which one isn't. Now you've got two different types of graphs. This is called a scatter plot, and this is called basically a function. Now we've been dealing with a function all year long. So as you can see, this is distance and time. So distance equals rate times time. So if I said something like, okay, after, let's say it's 1, 2, 3, 4, miles, average speed 20 miles an hour, I'd be able to take the distance 4, and I'd actually be able to put in my rate 20, and I could calculate anything I need to about the time. See, this is a function. So I'd be able to answer exactly how much time it takes to go 4 miles at 20 miles per hour. This is not a statistical graph. You can see it's a linear function. So I can calculate exactly what I need to find here. It's like, what year were you born in? 1967. How long are you going to be on the road if you go 4 miles at 20 miles an hour? You can find out exactly that piece of information. Now look at this. This is the distance to school, age of the person. So we got 10 years old, 20 years old. Here's the distance from the school. So you can say, okay, a young guy is only a mile away. Older person kind of further away. So we can make a conclusion. It's called a scatter plot, but we can kind of make a conclusion based on these statistics here. Younger you are, the closer you're going to be to school. So this is considered a statistical graph. This is not. We can make conclusions, but these are facts. These are generalizations based on the information. Okay. Question, what type of statistical variable, now that's a fancy word, there are two kinds. One of them is categorical, The next one I'll show you in 2 seconds, and then you can kind of compare and make sense of it. But a nice clue is, look at, there's different, let me back up. The question is asked to a certain population, what's your favorite Olympic sport? 25% said track, 25% said basketball, 20% swimming, 30% gymnastics. These are in categories. You can literally see it, hence the name categorical. All right, well, now, let's stop a second. Okay, so I took this example from the book, but not from the book. This one kind of threw me for a loop, and I'm going to do my best to explain it because I didn't think the example in the book really explained things too well. Maybe I missed some information, but this is what I'm going with. So remember, categorical is one of the 2 statistical variable types. So that's if the information gets thrown in a category, and you can make a conclusion. What's the most popular one? Well, gymnastics. Least, swimming. Okay, that's thrown into a category. Now, this here, this is supposed to be a phone, and this is the age of individuals. So 35, 40, 45, 50, 55, 60, and number of apps. And you're kind of looking at this, and you could say a lot about this information. And so based on that, let me double check here. Okay, so look at this. It's a quantitative statistical variable because we can really look at this and make some conclusions. We could say, this age group about the same as this age group. The 45 to 50-year-olds, for whatever reason, have more apps. What does that mean? They might be in business. They might, be in their careers. They're not. They might be in school. Maybe they have young families. They don't have time for all those apps. You can make all these conclusions. That's why it's quantitative. So you can throw your theories at it here. These are just facts. Facts, categorical. Something you can interpret, quantitative. Now, I guess I should say, you could argue you could make a lot of conclusions here too. But look how they're like just stacked in these categories. And this is more of a interpret the information. So keep that in mind. So, a couple new definitions for you. Go to page 553, example 3. Again, I'm going to summarize this, but essentially, it's talking about a group of students being surveyed. Now, it's a group of students at a school. And what they say is 30 students were selected. Now, what is the population? The population is the entire school. Now, again, they're not going to take time and interview every single student at the school. What they're going to do is take a little cross-section of that, which we call the sample. And so the sample size would be these 30 students. Now, if you look at the picture they give you freshmen, they give you sophomores, they give you a little picture of juniors, and then they give you a picture of seniors. Now, in the language of the problem, it talks about their interest in making conclusions about the sophomores. So the sophomores would be another sample. So they would take the number of the 30 students that were sophomores, and however many that would be another sample size. So the number of sophomores, let's say there's like 6. So they take the information from just the sophomores, and they would kind of make a blanket statement over all of the sophomores. So sophomores would be, two different ways you could look at it. The number of sophomores from these 30 students would be a sample, and they would make conclusions about those sophomores. So the number of people surveyed they represent the whole. So they're our sample. All right, think I said that well. So we're up to 3B on page 554, just to kind of really lock into this new thing called population and sample. So let's see. Okay, there it is. Man. All right, so it's a polling organization randomly chose eligible voters in the state of Illinois, to ask who they would vote for in an upcoming election for the governor, to determine who will win the election. What are the sample and the population in this scenario? So, the population, I mean, who are they really interested in figuring out? That's the entire state of Illinois. Now, who's the sample? Those surveyed. Okay, so again, they're going to take a percentage of the entire state. That could be 10 people, 20 people, 30 people, 1,000. The more you ask, the more accurate your information is going to be. But that number of people that they ask, that's your sample. It represents the population. Another word, new word, parameter. I'm going to define it for you. A measure that describes a population. So, the population is the target group of the study. So, statistic is a measure that describes a sample. Okay. So as you can see, they're going to ask you questions like, well, what's the parameter of this study? Remember, what are they trying to conclude? They're trying to conclude something about the entire population, hence the word population, of the high school. So the population. So what's the parameter? The whole population of the high school. Look at the definition here. Statistic is a measure that describes the sample. So the statistic that we got, I forgot how to spell it in a second. The statistic we got was 24%. And remember, that is from the sample of in a randomly selected lunch period. We don't know if that's first hour, first lunch, second lunch, or third lunch, but that lunch would be the sample. This would be the statistic, and our goal would be to make conclusions about the entire population / parameter. Here we go. Now, while you're listening to this one, remember the previous example. Only one of the 3 lunches was investigated. That's why it ended up being a statistic. And the statistic was something to be interpreted to connect to the entire high school. Now listen to this. This is from page 554, example 4B. At the end of its first year of business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales and number of tickets sold to calculate that the mean amount spent at concessions by a moviegoer was $8.14. Is this statistic or a parameter? Well, so the thing about this is they calculated all the money they brought in. This is not a statistic. This is a fact. So the $8.14 per moviegoer, that is not a statistic. That is a parameter because it is a study of the entire group. We got it in. Good luck on your homework.